What if I told you that the future of AI doesn't depend on just code, but on sand? See, we are in the middle of this AI thing. ChatGPT, DALI, autonomous vehicles, they all seem as if every day brings a new breakthrough. But there's something really crucial happening right behind the scenes. Something that most people are not talking about. It all comes down to this tiny little island in the Pacific Ocean, home to a company, again, you have probably never heard of, but one that's absolutely critical to the future of AI. But before we get there, we need to rewind a bit to understand who's really winning the AI race. Look at the landscape of AI development. Although large language models like ChatGPT and Claude represent the latest evolution in AI, these guys are coming much later. The OG AI did not involve so much as generative AI, but more of the analytical side of AI. That's like when companies like Google ran their search engines on the back of AI, or Netflix's recommendation engine, which also used analytical side of the AI industry. As we have already discussed in our previous video, the people who are responsible for the current wave of generative AI, well, that's where the paper AlexNet comes into picture again. Back in 2012, a group of researchers created something called AlexNet. It was a breakthrough in image recognition, rather generation, and it kicked off the modern AI boom. But there was a problem. AlexNet was built in a way that it would need enormous amounts of computing power, more than any regular computer could really handle at that time. AlexNet's success in 2012 was partly due to using two NVIDIA GTX 580 GPUs, a cutting edge approach at that time. However, the model was extremely resource intensive. The architecture consisted mainly of layers of neuron processing images through multiple layers. This increased their computational complexity and redundancy, which made each prediction highly resource demanding. This dependency on powerful hardware created a bottleneck for AI development even back then. Despite recognizing that GPUs were crucial for advancing AI, the available compute power still was quite limited. The true challenge wasn't just creating smarter algorithms, but scaling the hardware to match the growing complexity of AI models. At this point, one company emerged as the key player: NVIDIA, the same company that produced the two GPUs in AlexNet. Originally known for producing GPUs for gaming and high resolution graphics, NVIDIA quickly became indispensable to the AI ecosystem as the community realized that the potential of GPUs for AIs and parallel computing demands is unmatched. In 2006, NVIDIA launched something called the Compute Unified Device Architecture, or CUDA. CUDA is a platform that allowed developers to use GPUs for general purpose computing, including AI workload. This was the turning point. You see, this made GPUs versatile and accessible for tasks beyond gaming. And you can see that in NVIDIA's stock price. It has skyrocketed in the past 5 years alone, going beyond 1,000%. Why? Because every AI company in the world needs chips designed by NVIDIA. But here's the thing, NVIDIA doesn't make these chips, they simply design them. Well, who makes these chips, you ask? That's where our story really begins. Say hello to TSMC, Taiwan's semiconductor manufacturing company. This is the one company that makes over 90% of the world's most advanced chips. And not just for NVIDIA, but for Apple, AMD, and even Intel, amongst countless others. TSMC played it smart. You see, if NVIDIA sold shovels in the gold rush, TSMC produced those shovels as per NVIDIA's design. While TSMC handled the costly, complex process of manufacturing these chips at scale, the design-only business model allowed NVIDIA to focus on pushing the boundaries of GPU technology and design. In the last 5 years, while Intel and AMD have focused on CPUs and dabbled a bit into GPUs, NVIDIA has surged ahead thanks to its dominance in the graphics and gaming space. This gave them a huge head start to essentially win the AI race. AMD founder Jerry Sanders had famously declared, "Real men have fabs." a code that reflected the prevailing belief that owning your own semiconductor fabrication capabilities was essential to the success in the chip industry. But that changed when the margins on such facilities fell down, while the margins were shifting towards innovations in chip design itself. Unlike many competitors, TSMC rushed into this opportunity and adopted a strategy to focus solely on manufacturing chips for other companies. While companies like Intel and AMD originally handled both design and manufacturing, TSMC recognized a growing market for specialized manufacturing and committed itself to this very specific niche. This automatically made them a preferred vendor as opposed to, say, someone like Samsung, who owns fabs but also designs and uses them in their own branded consumer goods. For example, their Galaxy line of smartphones. In fact, this strategic focus has enabled TSMC to perfect its processes, advancing to the production of 5 nanometer and even 3 nanometer chips, while others are still struggling with high manufacturing costs, mainly due to low yields. That's a whole different short video for me to make, so be sure to subscribe. Anyway, TSMC now serves as the manufacturing partner for major tech firms, including Apple, NVIDIA, AMD, and even Intel, making it an essential player in the semiconductor ecosystem as a whole. But here's the thing, while making these chips is incredibly complex in itself, the machines that manufacture these chips are even harder to make. These modern 3 and 5 nanometer chips require something called an EUV or extreme ultraviolet lithography machine. These lithography machines cost between 180 and 400 million dollars each. These machines are so precise that even the tiniest vibrations can throw them off. And that brings us to the final piece of the AI puzzle. In Netherlands, this is ASML, a Dutch company that makes machines that make these chips. They're the only company in the world that can make the most advanced chip making machines. And without these machines, you can't really make advanced AI anything. So let's recap. NVIDIA designs the chips specifically for AI and other workloads also. TSMC manufactures those chips with high yields. ASML makes the machines used by TSMC. Every single major AI company in the world right now relies on this exact chain. As we analyze TSMC's remarkable success in the semiconductor industry, a pressing question still arises. Can we replicate TSMC's model? Although the aspiration to create similar companies is strong, the reality is fraught with significant challenges and longer timelines. Establishing a semiconductor manufacturing powerhouse like TSMC, for example, requires decades of effort. It takes years to develop the necessary infrastructure. Advanced technology and market trust are even more difficult to find. Founded in 1987, TSMC underwent extensive investment and innovation to reach its current dominance. New entrants must be prepared for a substantial commitment of time and resources before even contemplating completion, let alone success. This manufacturing process is highly sensitive, it relies on precise technologies, and is extremely expensive. For instance, the laser techniques used in photolithography are essential for creating intricate patterns on silicon wafers. These processes can be disrupted by even minor seismic activities. This highlights the need for careful site selection, and to maintain operational integrity, these companies must select locations that are seismically stable and free from geological risks. Plus, they need to be secure from geopolitical tensions as well. Regions with a history of earthquakes can pose severe threats to semiconductor fabrication. This makes the site certifications vital for long-term viability. The physical infrastructure needed for semiconductor fabs is substantial. From clean rooms to advanced machinery to purified water, the initial investment can range from $3 to $20 billion. This financial and geographical barrier presents a significant obstacle for new companies trying to enter the market, or even for old ones like Intel, to grow in this market. Even if companies do manage to navigate the challenges of building a semiconductor fab, they still face an insurmountable obstacle, the one of supply. And even if these extremely expensive plants are built, they still need to be housed with these extreme ultraviolet lithography machines, or EUVs, like we said, manufactured by this one Dutch company, which is ASML, like we told you earlier. So imagine being the only manufacturer in the world of a product that everyone desperately needs. By the way, side note, the lens company called Carl Zeiss also manufactured EUV machines and has now developed the next generation of EUV lithography called high NA EUV, but in partnership with, you guessed it, ASML again. EUV lithography machines are essential for producing the most advanced chips, capable of creating features as small as 3 nanometers or even beyond. And without these machines, any attempt to compete at the cutting edge of semiconductor tech is futile. This singular control has positioned ASML at the epicenter of the global semiconductor supply chain. But here's where things get even more geopolitically unstable, so to speak. The US has sent naval fleets to protect Taiwan. Because if China were to take control of Taiwan, they would essentially control TSMC. And if they control TSMC, they would control the current most advanced chip manufacturing facility in the world. And this is a concern not just for tech, but also for defense. Because a lot of these high end chips are used by defense contractors in their defense and security systems. These could be for missiles, or these could also be for detection and radar facilities. The current tensions between US and China aren't helping either, where there are concerns of China's allegedly stealing of top secret ASML designs and poaching former employees. This situation has sort of highlighted the vulnerability of these extremely sensitive technologies and the competitive landscape of semiconductor manufacturing, which not only involves scientists and computer nerds, but also spies for some reason. The US is so worried that they've passed the CHIPS Act, investing billions to try and bring the chip manufacturing back to American soil. But this hasn't gone well as expected, mainly due to critics pointing out that the size and the timelines of these investments wouldn't really be enough to win the semiconductor race. Building a chip factory, especially for the 3 to 5 nanometer and lower sizes, takes 1.5 to 2 years. It costs billions of dollars. And remember those machines from ASML? They are already on 2 to 3 year long wait lists. So, what does all of this mean for you? Well, in the short term, expect AI powered devices to remain expensive. The bottleneck in chip industry means high prices for AI companies, their investors, and hence their consumers. But in the long term, this could slow down the entire AI revolution as we know it. Without a breakthrough in chip technology or manufacturing, or even the way in these algorithms use the hardware that we know as of now, we might hit a wall in what AI can do. Thankfully, the delivery time for ASML's next generation EUV lithography systems, called EXE, are expected to be much faster. The EXE platform has a high numerical aperture, NA, of 0.55, which means it has better resolution and it can produce smaller transistors with higher densities. But even these machines would be available in full production mode only around 2026. So the next time you hear about an amazing new AI breakthrough, remember, it's not just about code, it's about hardware, it's about design, and it's also about naval ships. And right now, that hardware depends on a fragile global supply chain that centers around this tiny little island in the Pacific called Taiwan. The real winners of AI revolution might just be the companies you have never heard of, quietly powering the future away from spotlight, behind closed curtains, and in clean rooms. If you like this video, please make sure you hit the like button, hit the subscribe button, and more importantly, share this on LinkedIn and also on your specific AI lover groups. I would love to hear more from you guys in the comment section, and I'll be down there to talk to you guys. Thank you so much. And if you feel like recommending something for us to cover, do let us know. Thank you so much. And that's all from Easy Commerce.